When designing an electric hydrofoiling boat, a super optimized powertrain is really important. In this video, we will show you how we have done it.
This super compact pod has one motor in the front, one motor in the aft, and it can deliver so much power so we can foil with our 8.5 meter boat with 8 people on board, and it's super efficient. When we started developing our new boat, the C8, we wanted a more efficient drivetrain. We had a really good drivetrain on our C7, but now we wanted to increase efficiency, get rid of all maintenance and lower the noise. That's why we did the C-POD, a fully submerged pod motor with dual rotating propellers. Here's the AFS, the aft foiling system, where we have the rudder with all the wiring internally. We have the foil and we have the pod with the contra-rotating propellers, one motor in the aft and one motor in the front.
One of the main challenges with direct drive is the fact that the motor is spinning at the same speed as the propeller. An electric machine, especially as small as this one, is typically most efficient at higher speed, whereas the propeller is most efficient at lower speed. Instead of having one big motor, one big propeller, delivering the torque that we need, we split the torque up into 2 motors and 2 propellers. Then we are able to reduce the size of both the motors and the propellers. Also, with a smaller propeller, the tip speed will be reduced for the same rotational speed. That means we can stay below the limit of cavitation even with a high rotational speed of the propeller.
The comparison between one propeller and 2 contra-rotating propellers is that after one propeller you have a water flow that is rotating, and that we catch with a second propeller to get the efficiency increase a lot.
We have a few things that makes it super robust and where we have reduced complexity. One part is quite obvious, is the transmission or the lack of transmission with the direct drive. No gears, no oil, less complex. The other part is the passive cooling system. We cool the electric machines directly by the seawater on the outer surface of the housing. We have no rotating parts in the cooling system, no cooling fluids, which reduces complexity a lot.
The optimization work around this pod motor has been hydrodynamics, propeller efficiency, motor efficiency. To get that, all these 3 functions working together, we're stressing the most of the motor. We are making our own propeller designs and making everything by ourselves to get everything super slim, to have the lowest drag and high efficiency of the machine.
So we're trying out the new propeller set. This is our 3rd iteration now.
I think the marine propulsion systems will look like this in the future. And this is fully scalable, so we can build for bigger and bigger vessels.
Compared to the old world technology, we reduced the energy consumption by some 80%.
The experience of boating in the future will be electric hydrofoiling, and that is the most smooth ride you can have, and it's efficient, and we have it already today.
Brilliant design is about reducing complexity, and this is what we have done.